Yes. Yeah, good evening all. Yes. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right?
Yes, sir, it's visible.
Thank you. So myself, I'm Vijay, like I hold nearly 17 plus years of experience, which includes nearly 8 plus years of experience in Hadoop and Spark environment. So as part of today's demo, I'll be covering the following topics like what is big data, why Hadoop and Spark, drawbacks with the current databases, current databases, Hadoop advantages, Hadoop components, Hadoop and Spark job market. Yes. So this is what I'll be discussing. What is big data? So the name itself saying like huge volumes of data, right? Big data, nothing but huge volumes of data. So currently, if you take how the data is getting stored, like KBs of data, MBs of data, GBs, terabytes, petabytes, exabytes, zettabytes, petabytes, ottabytes, so on, right? So from TB onwards, like we say, like huge data, you should have seen like KBs, MBs, or GBs, or even TBs of data. Do you think like petabytes of data is it getting generated in the current real world? If so, examples of this petabytes of data generation. Try to give the examples of this petabytes of data generations. 1 petabyte, 1024 TBs, right? 1 petabyte equal to 1024 TBs. Already TB is a large storage unit, right? So if you take example of a banking sector, right? Like if you take example of any bank like SBI or HDFC, within the city, right, you see like hundreds of branches for it. Within the entire state, you see like thousands of branches. Within the entire country, you see lakhs of branches for this SBI. Again in each branch, right, you see like millions of customers, right? Millions of customers making multiple transactions, right? Per hour, per day, per month, per year. Each and every transaction has to be stored, right? Huge transactions, you can see, right? Means huge data is getting generated, right? Yes. Okay, forget about this banking sector. You are aware about social media like Facebook, right? Yes. Facebook. What is the data generated by Facebook in a minute? Means Facebook has got users not only within the country, it has got users throughout the world, right? Millions and trillions of users for Facebook. In a minute, how many posts and videos are getting circulated? What is the data generated by a minute? Not only like Facebook, you have got many other applications. We have got many applications which are generating huge data today. Just 1 minute transaction generating petabytes of data. 1 minute transaction, right? If we talk example like Facebook FB, Facebook posts, Twitter tweets keeps on generating Twitter tweets, and everyone you are querying in the Google, right? Google queries. What is the data generated by Google in a minute? What is the data generated by Facebook in a minute? Twitter tweets, or if you talk, everyone creating their own videos and uploading in the YouTube videos upload, right? Yes, YouTube videos upload. What should be the storage capacity to store all the videos? Or if we talk about email or Gmail messages, so millions and trillions of users. their messages getting stored, right? And what should be the storage capacity to store all this? Just now I was talking about the bank transactions. Bank transactions, right? What should be the storage capacity to store handle this? And similarly, like telecom transactions, right? And e-commerce, right? Like Flipkart or Amazon transactions. Everywhere we see like huge data, right? If you take Google and an average, it is generating more than 450 petabytes per month and an average, right? Means 450 into 1024 TB is the data generated by Google and an average, right? So currently we have got a databases. Currently we are going with databases. We have got databases like Oracle, databases like MySQL, right? Like DB2, Oracle, MySQL, DB2, SQL Server, like different databases. These databases used for OLTP, online transactional processing, for day-to-day operations, but we have got some specialized databases. So we have got some specialized databases, like if you heard about Teradata, like or Netija or Vertica. So these are the specialized databases, right? So these normal databases, they can handle GBs of data, like, and specialized databases like Teradata, Netija, Vertica handles TBs of data. But to handle petabytes of data, right? To handle huge data or petabytes of data, unlimited data, whatever it is in GBs or in TBs or petabytes are higher than that. To handle that huge data, we have got a framework, right? Like Hadoop. Hadoop is a framework for storing unlimited data and for processing unlimited data. I'll come back to this Hadoop, right? But before that, you need to understand the data generation, right? The data generation, how this data is getting generated. Is my voice clear to all? Once again, can anyone please confirm?
Yes.
Yes, sir.
Yes, sir.
So if you talk like from the last 50 years, the data generation, if you take, for example, 1973 to 2023. Yes, from the last 50 years, that this is the data. Assume this is the data, right? Which got generated from the last 50 years. Observe from the last 10 years. If you see from the last 10 years, 2013 to 2023, last 10 years, compared with the previous 40 years, only 20% of the data what we see has been generated in the 40 years of 1973 to 2013. Nearly 80% of the data what we are seeing currently has been generated from the last 10 years, right? 10 to 15 years, the whatever that huge 80% of the data in the current world has been generated from the last 10 years. What is the reason for huge data generation, especially from the last 10 years? Means because of usage of technology, usage of internet, and usage of smartphones. So if you see before in 1990s, the usage, if you see, we have got the secondary storage devices like floppy disks, just 1.44 MB. Used to carry data in floppy disk, just 1.44 MB. Later you got compact disc CDs, later you got DVDs, later you got USB pen drives, right? So as day by day, as the data increasing, the storage systems also getting increased, right? Now, in the earlier stages of mobile phones, right? See in 2000s or 2001, right? When the earlier stages of the mobile phones, just 256 MB, right? Or 128 MB was a big storage, internal storage, right? Now even 128 GB is small storage now. So slowly we'll be entering into GBs, TBs. Now you are getting petabytes of data. And what are the main sources from where you are going to get this data from? What are the main sources? Mainly you see like the three sources of data. You see mainly three sources of data, right? You see like the social data. Machine data and the transactional data. Social data, machine data, and the transactional data. Social data means data which got generated from the social sites like this Facebook, Twitter, all this, right? Machine data means data, the name itself saying, right? For example, if you go to a shopping mall, for the items you purchase, a big bill is generated, right? Means the data which is generated by reading or scanning the barcodes, RFID chips, such kind of data we call like machine data. Transactional data like day-to-day transactions, bank transactions, telecom transactions, right? And this data which is generated is only mainly occupying three formats, three forms, right? Three types of data, I can say. Three types of data, right? Three types of data is nothing but structured data, semi-structured data, and unstructured data. Yeah, what is that? Structured data, semi-structured data, and unstructured data. Structured data means data which is organized in the form of rows and columns. Example like Excel tables, Excel files, DB tables, database tables. Semi-structured like see like XML, JSON, all this, right? XML files, JSON files. Unstructured like articles, short messages, images, videos, etc. Right? All are unstructured. But today the biggest challenge is, right, how to handle this unstructured data. Today, like 80% of the data, what we are seeing, most of the data you see in unstructured format. But the current databases can handle only structured data. This is the form of rows and columns. But to handle unstructured data, the biggest challenge to handle unstructured data. So databases cannot handle this unstructured data or semi-structured data like XML files, JSON files, right? But Hadoop can handle all varieties of data, structured, semi-structured, and unstructured, right? So day by day, as the data is increasing enormously, we need to have proper storage and processing systems to store that huge data and process that huge data. As a solution to all the storage level problems and processing level problems, so there is a framework got introduced like Hadoop, right? Hadoop framework. So this Hadoop is meant for two things. It is meant for two things, for huge data storage and for processing, for storage and processing. If you take any technology, right, either C or C++ or Java or .NET, all these, they are meant for processing. If you take any technology, they are meant either for processing or for storage. For example, Oracle, MySQL, DB2, all these are meant for storage. If you take any technology, is meant either for storage or for processing. But Hadoop is meant for both storing and processing. That too, huge data, unlimited data storage, and unlimited data processing. You may get one query, you may ask a query, right? Okay, when Hadoop is able to store that huge data and Hadoop is able to process that huge data, then what is the necessity of these technologies then? When Hadoop is able to do all those, right? So you need to clearly understand Hadoop is for batch processing. Hadoop is for batch processing. Hadoop is not for online processing. For a single record, for a single transaction, Hadoop is not required. For millions and trillions of records, Hadoop required, right? Batch of for huge data processing, we go. Hadoop is good for huge data. Hadoop is bad for small data. So here some more queries. For storing the data, does Hadoop use any database internally? For storing the data, does Hadoop use any database internally? No, I am saying like databases has got some drawbacks. Despite of those drawbacks, still Hadoop doesn't go with databases, but it is going with a kind of file system called Hadoop distributed file system. And for processing, we are going, is it going with any current technology like Java or C? No, it is going with a parallel execution model called MapReduce and Spark, right? For high speed processing, for huge data storage, can store and process the data. Understood, right? Hadoop is meant for storing and processing. So if you take big data, we take big data as a huge data storage, huge data generation, as take big data as a problem. It's a Hadoop as a solution. If you take big data as a concept, it'll say Hadoop as the implementation. All right. So for storing huge data and for processing this huge data, right? Yes. Observe. Drawbacks with the current databases. What are the drawbacks you observe, right? So before that, Hadoop is meant for, yes, Hadoop is meant for two things. First one like storage. Second is like processing. For storage, right? Yes, we use like HDFS, Hadoop distributed files. So in this course, you'll be learning both the technologies, right? Like Hadoop and Spark. Previously, there were two separate courses. Now we have combined both Hadoop and Spark. Spark is a very high speed processing technology, right? Yes. And this is for processing. We'll go for MapReduce or Spark. Now Spark, right? Yes. Okay. Drawbacks with the current databases. Drawbacks with the, okay. So Hadoop is meant for batch processing. Hadoop is meant for batch processing. What do you mean by batch processing or batch applications? There are two types of applications. There are two types of applications, right? Yes. First one, online applications. Second is like batch applications. What do you mean by online applications? See, Hadoop is meant for batch applications, not for online applications. User interactive applications, right? What are these online application? User interactive applications, right? Here, user gives the input. Here, user gives the input. Here, user provides the input. So example of online application, example of this online application, example, booking a movie ticket. Here user input is required, making an online transaction. Okay, batch applications, right? Batch applications, user non-interactive applications. user non-interactive applications. User non-interactive applications. Here user won't provide any. Here user won't provide. User here user is nowhere required. Nowhere required. Example. Here user is nowhere required. Example. Railway ticketing PNR status. Railway ticketing PNR status means, for example, today the status is 200, waiting state is 200. After 2 hours, it is 150. Tomorrow morning, it is 70. Tomorrow evening, it got confirmed. Means it is happening in the background. It is happening in the background, right? Here, user is nowhere required. So here, credit card statement generation for millions of customers. Similarly, phone bill generation, phone bill, right? Statement generation. See, most of the financial applications. Most of the financial applications are batch applications. User is no way, right? User is nowhere required. So Hadoop is for batch applications, right? It's not for online applications. Okay. You may ask why databases. I got a query, right? Why databases? Why databases like Oracle are not used to store Hadoop data?
Sir,
Why databases like Oracle are not used to store Hadoop's data?
I have a question, sir.
Yes.
Batch processing, is it the same thing as OLAP? OLAP?
Yes.
Or data,
Yes.
data warehouse.
So here I was talking, right? Okay. Databases are used for OLTP. Specialized databases, they are used for OLAP, analytical processing, online analytical processing. So here, these are not for batch this Hadoop is not for online applications. Therefore, batch applications, right? Batch means user interactive. They are not user non-interactive applications. For analytical, you can say.
Just like data warehouse.
Yes. So yes, in Hadoop, we have got a component called Hive, right? Where it is a kind of data warehouse kind of environment in the Hadoop framework. All right. Fine. Drawbacks of current databases. So if you got knowledge on this database, one second. Sorry, drawback of current databases, right? Yes, drawback of current databases. Limited storage. Most of the databases you see like limited storage, right? In GBs or TBs. Limited storage in GBs or in TBs. Second, most of the databases, no parallel processing. In most of the databases, no parallel processing. Okay, third, as volume increases, speed decreases, right? Speed decreases. Means, for example, if I'm taking a query, select total amount, sum of amount from, select sum of amount from sales one, right? Select sum of amount from sales one. Select sum of amount from sales one, right? So assume that you got some 10 records in this. Sum of amount from sales one, right? 10 records. Select sum of amount from sales two, sum of amount from sales two. If you got some 1,000 records, select sum of amount from sales one, 10 records. Select sum of amount from sales to 1,000 records. Think that you got some 1 lakh records. Select sum of amount from sales 3. I've got 3 tables. Select sum of amount from sales 3. See, it has got some 1 crore records. Which query is going to execute faster among these 3? Total amount from 10 records or 1 lakh records or 1 crore records?
First one.
First query is going to execute faster because query to query, as the volume increasing, speed decreasing, right? As volume increasing, speed decreasing. First query execute faster, next the second, next the third, right? So as volume increasing, speed decreasing. So it's just like okay. Next, like if complexity increases, speed decreases. Speed decreases, right? Complexity increases, speed decreasing means, for example, even if you talk about this human brain, what is 3 into 4? 12. 7 into 6?
42.
42. 12 into 6? 72.
72.
12 into 13? 273 into 574. So here, complexity increasing, speed decreasing. The same way here, if you see, if you take a query like select sum of amount from sales one, right? Okay, if you got some, okay, if you got some 1 lakh records. Select average amount. Select average amount. Select average amount, right? Select average amount from sales one. Okay, select average amount. It has also got 1 lakh records. select standard deviation of amount from sales one. Sum of amount from sales one, 1 lakh records. 1 crore records. So same, observe this, it has also got 1 lakh, 1 lakh, 1 lakh. So here I want the sum of amount from sales one, average amount from sales one, standard deviation of amount from sales one. From sales one, so I want the same 1 lakh records, 1 lakh records, 1 lakh records. Which query executes faster among these three? Obviously the first query, right? Sum of amount, because average amount is a two-step process. First sum has to be calculated, next average has to be calculated. Standard deviation of amount, right? Means lot of internal processing required as compared to the first query. Second and third query takes more time. And the major drawback of databases is databases can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured kind of data. For example, you want to take reviews for a particular movie. User giving the reviews, right? User and a review. Okay. User 1, user 2, user 3. In this way, 100 users giving feedback, right? That is reviews for a movie. Okay. User 1 saying the movie is good. User 1 saying the movie is bad. 3% saying movie is good. So they are giving the feedback or reviews in the form of zeros and one. Can you write an SQL query to count the number of ones and zeros? This data isn't structured in form of rows and columns. Can you write an SQL query, right?
Yes.
Single grouping and single aggregation, right? Yes. Select, try to say select a review wise, I want to count. Review wise counts from which table? Okay, I think this is a reviews. The table name is reviews. From reviews, group by review. Okay. Output you see review wise means 1, 0. Count of 1 is 90. Count of 0 is 10. Review wise count from reviews, group by review, 190, 0, 10. Okay, fine. So 90 people saying the movie good, 10 people saying the movie is bad. But generally reviews won't be given in the form of zeros and ones. Reviews will be given in their own text format. Like movie is good. First person saying movie is good. Second person saying movie is not good. Third person saying some, okay. So they are giving in their own text format. Can you write an SQL query now to say how many people saying good, positive feedback, negative feedback, right? Sentiment analysis we say. So movie is good, movie is not good. How many people saying it is good? How many people saying it's not good? Can you write an SQL query now? Not possible, right? This kind of data, it can't be handled, right? So even if you go with keyword count, keyword like good, it gives wrong computation because even not good is having good within it, right? So this kind of data can't be handled. Now, databases can handle only structured data. Now, yes. Now, before I go with Hadoop advantages, what is? before I go with Hadoop advantages, right, you need to know something about this Hadoop architecture. I'll just give an overview of it. Not later, I'll discuss in brief about it. So as it is a demo session, so I'll be just briefing, just give overview of it. So Hadoop follows. Hadoop is not, see here, it's not a web applications you are developing here, batch applications, right? So here it's not like client server. Hadoop doesn't follow client server. If you are giving a request, getting the response, right? It's not like client server. It's like master slave architecture. Hadoop follows master and slave architecture. Single master, multiple slaves, multiple slave systems, right? Yes. So here, multiple slave systems, all these are interconnected, right? Yes. Okay, one too many, right? Slave one, slave two, slave n, right? N number of slaves. So these are single master, multiple slaves. Single master and multiple slaves, right? Hadoop follows master slave architecture. Why? How Hadoop is able to accommodate huge data or unlimited data? How come Hadoop is able to accommodate huge data or unlimited data? It's not like server, right? It's master slave, single master, multiple slaves. All these are interconnected. This we call it like a cluster. This we'll call it as a cluster, Hadoop cluster. Group of CPUs connected in a network. In that, you'll have one master and the remaining all are slaves. In Hadoop, data is stored in the form of files. f1.txt file, assume it is of 2 TB size. Assume the size is 2 TB. Each hard disk capacity 1 TB, 1 TB, 1 TB, right? Each one hard disk capacity is of 1 TB, 1 TB, and 1 TB. This 2 TB file cannot be fit into any of this system, right? Because their size is 1 TB, but the file size is 2D. So in Hadoop, the data, the file will be splitted, will be divided into smaller chunks. We call them as blocks, fixed size blocks. Yes, each one will be stored across the multiple systems. Each one stores across the multiple systems. Means think 10 lakh records in this, 10 lakh records in this, 10 lakh records in this. Data is distributed. So data is distributed. This data, the Hadoop's data, the files data is distributed across multiple systems and are processed parallelly. Two advantages what you are going to see here. Two advantages what you are going to see here. One is distributed storage, and you see like parallel processing. You see like parallel processing, distributed storage and parallel processing. Yes. Okay, so if the data is not distributed, then no parallel processing. So here data is distributed. If the data is increasing, your slaves will be increased.
So I have a question.
Yes.
Hadoop, is it a software that you install, like where you install like database, Oracle, or SQL Server? Do you install Hadoop in that format? Is it a software that you can install?
Oh, yes. Okay. And I'll provide you the software, right? It's not a software. It will be very easy to install and you can work on it. So I'll demonstrate about those later. Fine. Your this whatever softwares, right? It can be installed in any system, right? There is no separate configuration required. Okay, fine. So here data is distributed. Okay, if your data increasing, your number of system slaves will be increased. So data horizontally unlimited scalability, we say horizontally. If your data is increasing, your slaves also will be increasing horizontally. That's why horizontally unlimited scalability, right? Yes. So now coming back to Hadoop advantages, right? Hadoop advantages. Hadoop advantages. First one, unlimited data storage, unlimited data storage. Second is very high speed processing, very high speed processing because of parallel processing, right? Yes. And third, unlimited data storage, very high speed processing, can handle all varieties. Yeah, slave means systems, right? Slaves means what? System, CPUs. Can handle all varieties, can handle all varieties of data. Varieties of data. Open source. What is it? Hadoop is an open source. No licensing required. More than the hardware, the software licensing will be more costly, right? Hardwares will be cheaper than the softwares. So here, commodity hardware. Commodity hardware means it is not like a very highly configured systems, not Hadoop can run on any system, right? Okay. If speed increasing, if the volume increasing, even speed also increases here. No, it won't decrease. Fine. So main advantages like unlimited data storage because data is distributed, very high speed processing because of parallel processing, can handle all varieties of data. So open source, right? No licensing required, and commodity hardware, right? Yes. Now, very high speed processing, right? I will just to show you the speed of Hadoop as compared with the other things. Yahoo has conducted a test. Yahoo has conducted a test to check the speed of different databases. It has taken, Yahoo has taken a table. It has taken a table, right? Of 100 TB consisting of 1024 columns, and the task is sorting based on 16 columns. So here Yahoo taken a table of 100 TB consisting of 1024 columns, sorting based on 16 columns. So time taken by different databases. Time taken, right, by different. First, Oracle. Oracle has taken nearly 3.5 days to process it. MySQL has taken nearly 6 days to process it. Teradata, right? Used for data warehouse purpose, right? It's a kind of data warehouse. Just 4.5 hours it has taken. 4.5 hours. Netija, another specialized database. This is also used for data warehouse purpose. Has just taken 3 hours, right? Finally, Hadoop has just taken has just taken 4.3 minutes The latest version of Hadoop has just taken 2.4 minutes, right? Latest version of Hadoop has taken 2.4 minutes. That is what the speed of Hadoop as compared with other things, right? So Hadoop is proven in the market processing point of view and storage point of view. Storage point of view, I'll just provide you multiple examples in the tomorrow session. But see this processing point of view, right? It's very high speed as compared with the, so if you see most of the data warehouse kinds of projects are migrated to Hadoop and Spark environment. Data warehouse kind of environments, that kind of projects, right? They're
Yes, sir.
migrating.
Actually, one of my project also migrating actually now. It is the Vodafone, Germany. We are migrating to GCP Hadoop now.
Yes, most of this.
Just example, yeah.
So Oracle and SQL Server, which one is faster? Oracle database and Microsoft SQL Server, which one is faster in processing?
So here I'm not talking about Hadoop doesn't use any database, right? For storing or processing. So databases are not required here. They have got some drawbacks. It is not using any database. We are going with a file system called Hadoop distributed file system. We're not using any database, right? So, but from where you are going to get the data from databases, from different databases, you are going to pull the data, huge data. If you got 4 branches, if you got 4 branches, right? Yes. From 4 branches or from 10 branches, you are going to pull the data into a single place like Hadoop HDFS, right? You are be storing there. From there, again, you will take the data as input and you are going to process the data using these processing tools like Spark, MapReduce, or Hive, that what we'll be discussing. Takes that input from this Hadoop HDFS and process it. Again, stores the data back into HDFS. Fine. So now, up to now, I discussed about the Hadoop, right? Hadoop 2.5 minutes as compared with other databases. Now, so, okay, if I talk about PySpark, now, just PySpark, Spark. Already Hadoop is okay. Hadoop, right? It's very high speed processing, high speed storage. It's used for both storage and processing. As compared with the other things, Hadoop, see the time taken, very high speed. This is Spark, 100 times faster than this Hadoop. 100 times faster than this Hadoop. In-memory computation, you are storing and processing both happening within the memory level. Within the RAM level, data gets stored. In RAM level, data is processed. What is Spark processing? Spark processing means in-memory computation, in-memory processing. In-memory processing means your data won't be stored in the disk. Your data going to be stored in the RAM and processed within the RAM. Generally, your data stored in the disk and processed, right? But in this Spark, data storing within the RAM and processed within the RAM. And that's why companies which can, who wants high speed, they go for Spark. But one thing, they need to maintain huge RAMs to store huge data, huge RAMs to be maintained. Otherwise, you can go for Hadoop. So, but there are some components in Hadoop which you need to understand before for Spark, right? Because they are used in Spark, like Scoop, Hive, right? HDFS, Scoop, Hive, these things you need to, Yarn, all these things you need to understand. There are some Hadoop components like HDFS, Yarn, Hive, Scoop, even like NoSQL database like HBase that you need to understand, right? For under Spark. Fine. If I talk about Spark, PySpark, right? What is Apache Spark? What is means both the things we are going to cover as part of this Hadoop and Spark. What is so Apache product? It is Apache. What is Apache Spark? Why PySpark? Need for PySpark.
So you made the mistake from number 1.
Need for PySpark. Yes, for your general queries, I'll be giving time for the at the end of the session. Right, PySpark features. PySpark features. If you see, if you've got knowledge on this Hadoop and Spark, and you see that salary packages as compared with other technologies, right? It's data engineering, right? Data analytics. Okay. Yes. What is that?
You made mistake number
Uh,
1. What? The spelling.
Yes, yes. Every word is new word and very hard to understand these things. Dana, which word you are feeling? Which is the word?
No, sir, not words, sir. You say different types of databases, and these are
Don't, we are not using any database, right? We is a drawback with databases I discussed. Drawbacks of databases I discussed. We are not using any database, right? Hadoop doesn't use any database. There are many databases, like how you use this SIMs, right? Like Vodafone, what is that? Idea. You have got many SIMs. In the same way, we have got many databases in the market. Just the databases names, right? But here I was describing the drawbacks with the databases and the Hadoop advantages. Hadoop advantage means very unlimited data storage, high speed processing. All varieties of data can be handled, open source, no licensing required, right? We are not discussing any database here. So in the speed of Hadoop, just I was compared with other other technologies, right? So Hadoop speed is way too fast, very fast, right? What is Apache Spark and why PySpark? Need for PySpark, PySpark features. Real life usage, right? Yes, of PySpark. PySpark job market. So here, if I say Apache Spark, Apache Spark, if I say, right, it is an open source distributed computing, right? Distributed in-memory processing, right? So open source distributed computing in-memory processing. This kind of in-memory processing, because of this in-memory, very high speed, you can see, right? So this Spark is a general engine. It's a general for big data analysis, processing, and computation, right? So why PySpark? Why PySpark, right? Yes. It is a Python API to use Spark. What is PySpark means? Python API to use PySpark, right? To use Spark. So just we say pip install PySpark to install this, the kind of a module, you can say, right, in Python. PySpark, it's a package, PySpark package, right? You will be installing using pip. So it's a Python API to use Spark. It is a open source cluster computing used for big data solutions, right? So I can say PySpark in current world, right? In the current industry, it's a lightning fast technology that is designed for fast computation, right? It's a demanding tool among data engineers, right? To work with bigger data sets, right? So generally this PySpark used for what? PySpark used for running distributed SQL. So data is distributed, even this parallel processing you are going to see, right? creating data pipelines. Creating data pipelines means the output of this will be the input to the next, and next the output of that will be the input to the next. Data pipelines. Data flow, we say data flow language or data flow, right? Okay, fine, right? Creating data pipelines, ingesting data, ingesting data, right? Means how you are getting the data from different sources or from databases. So it's also PySpark used for running ML algorithms. So even it is supporting machine learning algorithms. That is the important thing, right? It also supports it also not only ML algorithms, right? Also like graphs or data streams. Graphs are data streams, right? Yes. Live streaming data. So need for PySpark, if I say, right? PySpark used for running distributed SQL, parallel processing, you see. Creating data pipelines, ingesting data. Ingesting data means you are pulling the data from different sources, running ML and graphs or data streams. Need for PySpark. Need for PySpark, right? Yes. See, a large amount of data is generating both through offline and through online. This data contains hidden patterns, unknown corrections, market trends, customer preferences, and the other useful business information, right? It is very necessary to extract valuable information from the given raw data. We require some more efficient tool, right, for performing these kind of operations on huge data or big data. We have got many tools already available, right? And for working on huge data sets, but the tools are not that much of appealing, right? So we require some flexible tools to crack big data and gain benefit from it. So PySpark is such a kind. So combination of Python and Spark. So already Python, like very less coding, it's a simple language, right? With many different types of modules available, right? And different multi-programmed language, hybrid language. So combination of Python and Spark will be very efficient for the world of big data. So Spark is a it has got multi-language support. Spark can be coded with Python, Scala, Java, or language. But among all those, mostly used is Python and Scala. So the combination of Python and Spark will be the very efficient for the world of big data. So Apache Software Foundation, the Apache Spark community came up with a tool called PySpark, Python API for using Apache Spark. So many features we'll be discussing as part of this course. And if we talk about real life usage, right? Yes. Real life usage of PySpark. So it looks very simple and easy, right? This we won't write many huge codings here. Already inbuilt functionalities are available for performing this processing, right? Yes, I'll come back to that requirements. So what are the prerequisites, other things? But real life usage of PySpark, mostly used in this commercial sector, right? PySpark used in this commercial sector. So it uses commercial sector means using this Apache Spark. We call it as real-time processing. Most of the time, banks and financial systems use this Spark. So here Spark is not a language. Python language will be used. Spark is an execution model. Python is the language. So we use Python language. Python coding will be done. And Spark is the execution model implemented using Python. Combinedly we call PySpark. commercial sector I was talking, right? Banks and other financial fields are using Spark to retrieve customers' social media profile and gain useful insights from that to taking the right decisions. DSS, decision supporting systems, we say. So they can be used for credit risk assessment. So Spark plays a vital role even in fraud detections and even in the healthcare, right? Healthcare. So to analyze the patient's records along with the previous medical reports history and to identify which patient is going to face the health issues even after being discharged from the hospital, right? So even for maintaining this patient's record and to analyze this and identifying the patient, right? And mostly today, if you see, PYSPARK is also used in entertainment industry. Entertainment industry means, yes. For example, the entertainment industry is one of the largest sector, right? So we're growing towards online streaming, the entertainment industry. So it's growing towards online streaming. The popular online entertainment streaming, like streaming, right? Netflix, right? Using Apache Spark for real-time processing for personalized online movies or web series. So it's processing 450 billion events per day. So what is that? It's processing 450 billion events per day. Okay, fine. Even in the trade and e-commerce, in e-commerce and trades, all right, like Flipkart, Amazon, etc. All they are using PySpark for advertising. Means like a kind of recommendations are done. If you are observed in Flipkart, Amazon, the persons purchasing this product also purchasing this, recommending you, right? Means if you are buying a mobile phone, they are recommending to also purchase. Most of those customers buying mobile phone also purchasing that mobile cover or earphones. So it's kind of recommendations are done to increase the business, right? So even for tradings and e-commerce also, right? For providing some kind of enhanced customer experience. And even in the tourism industry also, right? PySpark is mostly used in tourism industry. Okay. So it provides advice to millions of travelers by comparing with hundreds of tourism websites. Even comparison of two products. Yes. Yes. So based on the current data has got experience, data has got future reference. Using the data only, you perform data analysis, data predictions, data classifications. You are classifying the data based on data only, classification happens. Data analysis will be done. Data predictions are done. Okay, you will be predicting based on the current data, you are going to predict about the future. So for everything, data is important. So here in the big data, you provide data management and data processing. Data management, you are going data storage and processing, you are going to see. Most of the time people ask data analytics and data science. Data science is for data and analysis. Data prediction, right? You are going to predict, predictions going to be done, and data recommendations will be in big data, data analytics, right? Data management is be done, right? Data storage and data processing. So this typical data science, a data science depends, a typical data scientist depends on this data engineer, right? Big data guy. A typical data scientist will depend on the typical big data guy, right? Because first this storing and processing happens, later is analysis, predictions, all this will happen, right? We are going to apply the ML algorithms, those things, right? So here today day by day data is increasing enormously. We need to have proper storage systems, right? So Hadoop is meant for both storing and processing. processing, storing data and processing data, that too in quick time. Unlimited data storage, it is used for batch applications. So drawbacks of databases, despite of this drawback, Hadoop going with HDFS, unlimited data storage, very high speed processing, handle all varieties of data. It's open source, no licensing, commodity hardware, right? The speed you can see very less speed, right, as compared with the other things. And also like PySpark, very high speed processing in memory computation. So it's so both Hadoop and Spark. You can see, you can type in Google and check this Hadoop and Spark jobs. Lot of jobs are there, and even the salary packages are very high as compared with other technologies. Data engineers, or if we talk about this data analytics. Yes. Many freshers as a data scientist, you can go as a fresher. Many data scientist freshers are taken for data scientists, right? Anyway. So fine. Okay, that is your wish. Dana. If you feel it is hard, it will be harder. If you feel it is easier, it will be like you won't write any big huge codings, right? Even you are not going to write like Python codes that you used to write in Python. Those everything already inbuilt APIs are available performing all these things. Inbuilt APIs are there. So what are the things I'll be discussing as part of this, right? Yes. What is the course content, right? Yes. So both two courses will be discussed, Hadoop and PySpark, Big Data Hadoop. So first, what are the Hadoop courses? What is Big Data? Need for Hadoop? So these are the things, it's Satyajit Patil, right? So what is big data, sources of data, types of data, comparison with other technologies, challenges, advantages. HDFS in brief, Hadoop distributed file system. You have got some commands, all one-line commands are there, just like Linux commands, right? So before I go with HDFS commands, I'll be briefing you about this Linux commands, basic commands. So features of HDFS, name, what are that name node, data node, right? Metadata management. So HDFS in brief, map reduce execution model. It's a very, so map reduce execution model. Yes, after, yes, one second, I'll come back to your queries. Scoop is one of the important component, right? Scoop full form is SQL plus Hadoop. The first two characters of SQL, last three characters of this Hadoop form scoop. For bringing data from databases to Hadoop, from also taking data from Hadoop to databases. Import export operations for importing, for exporting, how to perform different operations. So how to, while importing, how to bring only the required data, how to perform groupings, aggregations, filterings, mergings during importing while exporting. Yes. How to bring data from different sources, yarn, yet another resource negotiator, right? So it has got powerful fault tolerance model also. NoSQL, not only SQL, right? So today NoSQL has got great boom. See, for data SQL, right? For databases, first record to last record, same number of fields or columns to be maintained. Means if you got 5 columns, first record to last record, the same number of columns need to be maintained in SQL. But in NoSQL, my first record will have 3 records, second record will have 5 records, third record will have 7 records, fifth will have 10 records. Record to record, different number of fields can be maintained. That's why NoSQL we say. SQL requires structuredness. NoSQL, no structuredness, right? We are going to discuss one NoSQL database, HBase, and Hive, one of the important component of this Hadoop, right? That's why I'll be discussing more time. Hive, HQL, just like SQL, HQL is their Hive query language. Just like SQL queries, we have got HQL queries, and we have got different tables, internal table, external table, and partition table, non-partition table, working with unstructured data, working with XML data, JSON data, URL, weblog data, right? UDF, UDAF, UDTFs, right? Yes, upon see in brief, we'll be discussing coming to the PySpark. Apache PySpark. We have got many inbuilt features, inbuilt functionalities, right? Where PySpark is providing all 2 lines, 3 lines, you can process the data, right? Or you can perform the task, which functionality to be used, which function to be used, right? PySpark sessions, PySpark parallelize repartitioning, broadcast variables, accumulators, PySpark RTD computations, persistence, PySpark core computations, groupings and aggregations, and various actions and transformations. All these are inbuilt. Directly we can perform this operations with this. If you want to perform union, or if you want to eliminate duplicates, or if you want to perform joins, or Cartesians, or co-grouping, or count by key count, all these are built-in functions for performing all those, right? PySpark SQL data frames. So data frames like pandas data frame, here also we have data frames, how to create data frames, and from row class, column class, with column rename, where, filter. See, all these are the functions. Using this function will perform these operations. We don't need to write code. Order by, group by, join, union, map, flat map, for each pivot, array type, right? Row to column. PySpark SQL functions, aggregate functions, window functions, timestamp functions, and when many built-in functions, PySpark, when exp or lit function, split function, substring function, translate, overlay, timestamp or to date, to format, month, between, explode, array contains, collect, set, map keys, map values, sum average, row number, dense rank, percentage rank from JSON tuple schema, like many functions are available with external sources, working with SQL, Hive integration with CSV, JSON transformations, narrow and wide transformations, and window transformations, deployment modes, local and cluster, PySpark application stages and task drivers, executors, streaming and integration with Kafka, right? So in advanced concepts will be discussed. Now, this is the entire course content. Fine.
Sir, I have a question. Like, since we are using Hadoop for batch processing, what about online transactions? Which what kind of a framework we would use? Is it PySpark or any other?
See here, whenever this Hadoop integrated with NoSQL, NoSQL is for online processing, right? Hadoop
Okay.
and NoSQL integration, where it can perform online processing. Hadoop can perform batch processing. Combinedly, both can perform online and batch.
Okay.
The future.
So we would use NoSQL.
NoSQL, right? Yes. So even I'll provide you knowledge on one NoSQL database. So even apart from this, I'll also provide you knowledge on this streaming data also, like Kafka. Okay, so this is the course content, right? Everything I'll be discussing step by step from the basic level to the advanced level, right? So the advanced topics. So everything will be easily understandable, right? So some queries were asked. 1 second, let me address this. So yes, can we do Hadoop and PySpark parallelly? Yes. So first, after some 2-3 weeks of Hadoop, right? You can go parallelly, right? So that basics of Hadoop and this HDFS, you need to have that knowledge. After that, you can go parallelly. What would be the timing of this? Timing of this will be from 6 o'clock to 8 o'clock every week. So today it will be 6:30, tomorrow will be at 6:30, but from next week it will be from 6 to 8. Fixed, right? It is only a weekend batch. If possible, okay, Saturday 2 hours, Sunday 2 hours, totally weekly 4 hours, right? It's a weekend batch. So totally 12 weekends it will take, right? 12 weekends means 3 months for all this Hadoop and Spark, 2 technologies you are learning, right? Yes. If anybody wants to go parallelly, if any PySpark batch starts, you can join it, right? Timing of this class. Tomorrow you can join it at 6:30, same time, right? So using the same link you can join. We'll discuss more on this. What timing, right? And tomorrow timing is 6:30, but from next week it will be from 6 to 8 evening, 6 to 8 IST timing, right? It's weekends batch, yes. Saurabh Singh, right? Yes. Yes. Yes, people from Ratan, I read AP. Yes, from Java background can choose for Hadoop and PySpark. Yes, so totally Hadoop and PySpark. So first, without Java installation, this cannot be installed, right? Everything are going to run on top of Java only. But here previously, if you go back like 10 years, totally if you go for MapReduce, other things, right? Totally implemented using Java. But now, because of huge codings of Java, it is got replaced with Scala. Now we are using Python, right? Like mostly Spark with Python implementation. For Hive, we use HQL, right? So yes, course duration is 12 weekends. It will be like 12 weekends, right? 3 months it goes. Right? 12 weekends, right? 12 weekends we are going to spend, right? Nearly 5 weekends for Hadoop and nearly 7 weekends on Spark I'll be discussing, right? Hadoop like 5 to 6 weekends and Spark also like nearly 6 to 7 weekends I'll be discussing, right? This is the course content you can see in brief, right? Don't think like we'll be writing huge codes here, like all are like simple built-in functions available. Yes.
Will there be any real-time project will
So
be
at the
working
last,
after this
at the
course?
last, I'll be showing you one flow, right? Project flow.
Okay.
It was our. At the last, I'll be discussing that, Srini, right?
Okay.
Are we going to use? So I'll be showing you most on this HDF yarn, right? So yes, promotes one, right? I'll be showing you on this yarn. So the cluster manager that we will be using is yarn. But at the last, I'll be showing you, I'll be giving knowledge on those, what you are asking, right? Yes, Satyajit Patil, yes, I'll be helping you on making CV, right? Yes, resume building, other things, right? Yes. Fine. So a typical 3+ years or 4+ years experienced person, how much knowledge, if that much of knowledge you'll be gaining from this, right? Step by step, I'll be showing you like how to process it. I'll be typing statement by statement and I'll be showing you, right? Yes. You will get great command on this. So you can also check the boom for this data analytics and for this big data today. So as huge packages are there for this, at the same time, they'll be expecting good command on this technology, right? Yes. Yeah. Cloud environment can be used, yes. I'll be briefing you them at the last, right? I'll be showing you, right? And I'll be showing you how to run this. So how to run on this, I'll be giving you the software in this VMware workstation. I'll be showing you. Later, I'll be showing you how to run on Jupyter, Jupyter IDs, Spider IDs, how we can write this course and how to run and execute. Fine. Okay. So I'll be, if I'm done with your queries, then I will stop for now. Right. We'll continue tomorrow. Tomorrow, same time, it's 30 p.m. You can follow the same link like this.
Yeah, I have a question here. So will you also cover the topics on APIs and also?
Yes.
Yes. Okay.
So we have got many things available, right? So even Spark SQL, right? In how to perform querying on the data. We've got data frame APIs.
And one more question is that you will be handling both PySpark and the Hadoop, everything, right? The entire session will be taken by you itself.
Yes, Hadoop and PySpark both will be covering, right? Yes.
Okay.
So you'll be getting the recorded, every session is recorded. You will be getting the recorded session. Even if you miss, as these are weekend batch, if you miss the session, you can go to the recording and attend the next session. If you have got any queries, you can ask me. Notes also will be provided, clear notes will be provided topic wise. So here, if you talk about, observe these notes. So this is the 7th PySpark better. If you talk about this clear notes 1, notes 2. So PySpark notes. So in clearly the notes will be forwarded. You can easily understand, right? With comments I'll be providing. Software also, yes, I'll be helping you with. Fine, right? Yes. So yes, tomorrow you can attend the session 6:30, same time using the same link, right? Yes. So if you're done with your queries, I will sign off for now. Meet you tomorrow, yes, same time at 6:30, right? Yes. Thank you all for your time. Thank you.
Thank you.